A light ray is set for minimum deviation for an equilateral prism made of material of refractive index 1.73. Prism is equilateral, that means angle of prism is 60 degree. Angle of prism, which normally denoted by A, is equal to 60 degrees because it is an equilateral prism, and mu value is 1.732, which is equal to under root 3. That might help in case of calculation. So angle of incidence and minimum deviations are. So here we can see that this is a equilateral prism. So its angle of prism is 60 degree, and here it is incident ray, which is set for minimum deviation. So incident ray is moving this way, and finally when after passing through prism it comes out of the prism, it goes that way. So overall deviation suffered by this ray is this, which is denoted by delta. And at this point, if we draw a normal to the surface here, then this is angle of incidence, say I1, and the ray inside the prism makes an angle R1 with the normal. And similarly at this interface, let's draw a normal here too, and here R2 is the angle of incidence in this case, and suppose I2 is the angle of emergence. What do you know about the minimum deviation? What is the condition for the minimum deviation? Minimum deviation is when angle I1 and I2 both are equal, R1 and R2 both are equal. In fact, the light ray which is inside the prism becomes parallel to the base if it is an equilateral prism. It is in fact equilateral prism. So it has to be parallel to the base. So this particular line must be parallel to the base in case of minimum deviation. That we can prove easily. Okay, so for minimum deviation, condition is I1 equal to I2. Let us say it to be I, and since I1 I2 are equal, then according to Snell's law, R1 and R2 has to be equal. So R1 equal to R2, say it is equal to R. Okay, here you can see that this is R1 and this is I1 minus R1, or you can say this angle is totally 90 minus R1, this angle is 90 minus R2 plus 60 equal to 180 degree. In fact, R1 plus R2 is equal to the angle of prism. So in case of minimum deviation, what we have here is 2R is equal to A. A is 60 degree. So R is 30 degree in this situation. Since R is 30 degree, now you can clearly see that this line is parallel to the base. Because this angle is 30 degree, that clearly means that this angle is 60 degree. That means this line is parallel to the base. So whenever there is a condition of minimum deviation, the light ray which is traveling inside the prism becomes parallel to the base if the prism is at least equilateral, is at least isosceles triangle. Isosceles will do. In equilateral prism also it will be true, of course. So now using Snell's law, we have to calculate the value of the I1, or we can say I. As we know that according to Snell's law, mu sine theta remains constant. So mu outside is air, so mu is 1 into sine theta, that means sine of I1 that we have assumed to be I is equal to mu inside, which is under root 3 into sine of the angle inside, which is R. Sine R means sine 30. Sine 30 is half, so it becomes under root 3 divided by 2. That means sine I is under root 3 divided by 2, which further means I is 60 degrees. As for any kind of deviation, we know that the general formula is delta is equal to I1 plus I2 minus A. Means this formula is applicable for all kinds of deviation, whether it is minimum or not. And in case of minimum, since I1 and I2 both are equal and we have assumed it to be I, then for minimum deviation it becomes 2I minus A. So angle of minimum deviation in this case is 2 times I's angle of incidence, which is 60, minus angle of prism, which is also happen to be 60 degrees. So it is equal to 60 degrees. So angle of minimum deviation is also 60 degree. So angle of incidence for this ray is 60 degree, and angle of deviation is also 60 degree, which is the requirement of this question. What is the angle of incidence and what is the minimum deviation? So that is 60, 60. So option B has to be the correct option to this question.